Okay, I think I can give the floor now to Stefan Trobans. Hello,
Okay.
Stefan.
Thank you, Eduardo, for the introduction and the right pronunciation of the name. I hope you hear all well what I'm saying. Then we can kick off
I hear you already.
to the next slide. So in here, I'm going to try to explain a bit what is the difference between bus branch and outbreaker modeling and where it originally is coming from. Linked to that, of course, topology processing. The term is already used quite some times in last week's and this week's session, but maybe a slighter deep dive into it, and then we'll end up with a summary of what was already sometimes said about the CGMES 3 versus 2.4. So if we go to the node breaker versus bus branch modeling, we need to start with our own proper tooling and native modeling. So here we are not speaking about CGMES or whatever kind of model yet, but we look in what is our tool doing and how we are representing the outside world into our application. And on the left-hand side, we see the node breaker, which is typically being built up with disconnectors in the image represented with the green diamond and breakers with the white squares, which are then connecting the branches, either a line at the right-hand side or a transformer at the left-hand side, to the bus bars in our system. This is typically a model that is also used where, as Sven said, you need the ability to switch. So historically, it was mainly used by online models in EMS and SCADA systems to supervise the grid. On the right-hand side, there were the models that one would call bus branch modeling representation. No switches are present except the ones that are really needed. So we have the busbar coupler of the substation in order to be able to have a solid or a splitted substation in our model. For the rest, transformers and lines are immediately connected to the bus bars. So there is no real difference between the objects that are used. It is just a selection on what do you want to include in your model. It's a choice of representation. What are your needs? What do you want to study? And what are you using this kind of representation for? Are you focusing on the easy and smooth model that is as light as possible? Then you are in bus branch, typically used for the long-term planning. While are you close to operations where you want the flexibility of shuffling around with the elements, then you are in the node breaker approach. However, and then Eduardo, you can click, the tool in behind of the calculation is using always topology processing, because we want to have a very clean and lean. Yes, at the time being, they were already into those kind of terms that are now looking modern, to the lineification of your model, but it was out of needs. Computing power was just not as developed as nowadays, so the need was there to have, during the calculation, a model that was as simple as possible and which was not having a lot or none at all zero impedance elements. And therefore, the topology processing built into your tool before making a calculation, will reduce the number of complex elements and reduce the number of elements in your calculation matrix anyhow, to make the calculation faster because you have a smaller matrix, and to avoid numerical stability from the beginning. So it was out of a necessity that this topology processing was included. But you see, as I indicated on the slide just before this, that the result of the topology processing is in both situations leading to a similar representation. So the driver behind it might be historical and out of need, but it still serves a purpose. If you are at the end of this process, then you are essentially ready to go also to see what will this give in the sim world representation. And I tried to put this in the next slide. That is it. Yeah. So we have the same drawings as we had 2 slides before, where we have the disconnectors, the green diamonds, we have the black squares, and we have the branches, the transformer or the line. What we do add in here are the connectivity nodes and the terminals, so the red dots, which are essentially the glue to build and stitch together in a well-defined way the model, because I did not draw those red circles at the initial diagram, because it will depend on the tool whether they are present or not, to make the connection between the different bus bar and switch objects. But here in the sim, they are needed, because you do not want to rely on any internal logic in the tool, but you must make it transparent. And so we will add the connectivity nodes and the terminals, which will be in the EQ instance data. When we are going to process this model, so to compute the topology processing, like shown in the slide before, we will end up with a set of topological nodes that are deduced from the state of the different switches, which will make that the connectivity nodes that are connected by non-retained zero impedance elements like the switches are represented as one single node, one single topological node. So there could be a one-to-one relation, as Shavdar introduced in slide 44, but it's not needed. So we can have an aggregation of multiple connectivity nodes into one topological node, and the terminals will be then contained in or referencing to the nodes again. Like Sven said also, it is very important to see that this is a result of a topology processing process. And there we will make the switch between the CGMES 2.4 and 3.0, because in the 2.4 we were using or seeing the TP as some kind of an input and an output. While if we use and we look at it after these reflections, TP is always some end result. It's an output on the topology processing that happens based on the available connectivity nodes and the status of the objects connecting them, the switches. That would mean that we really need to see it as non-persistent objects. And Eduardo, if we go to the next and last slide, on that slide that is having and containing far too much text, but we decided in order to hope it might become self-explaining and that you can read the text again and again and again as long as needed at your own pace and pace. In CGMES 3.0, we will require all models, both bus branch and node breaker, to be built up with connectivity nodes. So the bus bars that were in the first drawing will always be a connectivity node, regardless it's node breaker or bus branch. So don't think that if we are going to use CGMES 3.0, we need all to build node breaker models. No. It will be possible to model bus branch, but the connectivity nodes will be used. And as said, the TP will be computed based on the definition in the equipment instance data and on the state of the switches given in the SSH, the steady state hypothesis data, so that it is not needed for a tool that can execute the topology processing. So just consuming tool can calculate the TP itself before visualization. So it does not need to be exchanged, but it can be used as an extra set of data to be helping tools that are not capable of doing the topology processing in their way. CGMES 2.4, where we have the need of including the operation profile if you want to have connectivity nodes present into your model. And so there is the real difficulty that the TP, if the operation instance data is not provided, can of course not be calculated, and so it becomes at that moment input data. And so the TP must be exchanged and together with EQ and SSH profile. However, as Sven said, and I will not repeat because it was so beautifully said, that we have issues and challenges with hybrid models over here, as there is no guidance on how to represent the different elements, and that you then are falling back that if you have one bus branch that needs or that provokes that all the rest needs to be reduced to or minimized to that same level of detail. Anyhow, if you are to making the circle completely round, thinking about this, the second slide of my presentation, where there was the need of doing some topology processing in order to do a load flow calculation. That means, of course, that load flow results are done in a tool that did the topology processing. So they will link to the topology instance data. So once you have made that clear, then you see that the power flow results will always be linking to TP data. However, this is also possible after a node breaker modelization. So A lot of things are possible, but there is a lot of degrees and for interpretation, and that is what makes CGMES 2.4 the struggle that we are in, because this lack of guidance on how to have the hybrid models, how to link TP and topology processing together with node-breaker models is leading to all of those challenges. I hope this helped you understand what are the differences between the node-breaker and the bus branch and all of the challenges that people are meeting with it.
Thank you, Stefan, for your presentation. Does anybody have a question regarding that? Svein has. Oh no, Stefan. Yeah,
Wrong button.
Svein. Wrong button. Well, okay. You're safe, Stefan. Anybody else?
High-fiving, huh?
It was high five, yeah, definitely. Rui, yeah?
Yes, I was paying attention to this topology issue because it's very important. As you know, sometimes we use topology actions to avoid the change of the market. Okay, so we need to have the ability to create long lines and change the topology by selecting the switch breakers and on the network. So I was a little bit afraid that when you aggregate this information to avoid the zero impedancy branch, you lose the ability to create this topology change. Maybe it's my mistake, I didn't understand completely, but I was a little bit surprised by your diagram where the circuit breaker disappears, and that can be a challenge. Okay.
Mm.
You're referring to this first diagram in comparison to this second diagram, right?
Yes, I think it was the next. Yeah, yeah.
The one in SIM.
This
versus...
one where the circuit breaker is gone. Okay. Because we need to have the ability to create long lines to avoid and to increase the impedance and to avoid overloads. Okay. So we need the way to manipulate the data to create these long lines. And the way it shows here is that you are losing the circuit breakers and then you are not able to create this change of the topology.
Indeed, if I correctly understand the question, if you are in case of being in a need to make such a topological change, you will need a node breaker approach. Of course, you can do quite some special tricks by adding a specific busbar with a retained busbar coupler that would then be kept in your model, and you can close and open that. So then you have some kind of an bus branch-like modelization in order to cope with the challenge that your operation is facing. Well, that would for me be a workaround where you want to cope with the requirement of changing topology. What would be processing by opening and closing disconnectors. So your business case is node breaker driven, but your exchange format would be bus branch. So you will need to look for workarounds. And indeed, your closed breakers that are not flagged as a calculation relevant or to be detailed for calculation will be lost in topology processing.
Okay, thank you for clarification. Yeah.
Yeah, maybe it's important to distinguish between the data exchange and what's happening inside the two. So, as Steph was saying, you exchange actually the equipment and SSH, and then you apply the remedial action on that. So in a way, you don't apply the remedial action on the TP. So you can also see it in that way, because even if you do a contingency or other things, your power flow application will need to do bigger or light form of topology processing when computing the load flow for that given contingency or remedial action. There are some, kind of a workflow nuances that are sometimes hidden from the data exchange.
But you can also, the idea that you can have these virtual breakers doesn't need to be exactly the same as you have in your in the fields, but that is the way to do topology changes. So if you have a remedial action that require topology change, rather than we have two ways of describing that, we only have one using those breakers. But of course, we recommend that everything is aligned. We have one models that representing the current state. It doesn't prevent you from adding this information into the model if you're primarily having a node breaker. So you can then have this type of hybrids. But it means that all tools only have one way of understanding topology process.
Okay, I hope that helps, Hui. And I see Arend. Do you want to raise a question?
Yeah, I didn't put up my hand, sorry. But I have a question to Stefan. With the terminals on the left side, there are terminals within the breaker, for example, which can carry relevant measurements. So when you go from node breaker to bus branch, how do you keep track of those terminals?
You mean this?
Yeah. So you have
But what kind of business use case do you have in mind? Because are those measurements to be exchanged?
Yeah. So in case of a contingency, for example, so you have measurements on the breaker.
But then you
on the terminal of the breaker, and when you go to a bus branch, we are now connecting those terminals together. But I was thinking, where is that information?
But as I think Tanya was putting into the chat, if you have this explicit need to have it into the model, the switch itself needs to be flagged as retained, and then it will be included into your model, like the busbar coupler is also in the bus branch.
I want to condense the model to bus branch, so there's no need for the breaker. I only want the measurements on the terminal.
But then you have the TP making the linkage, because you know which topological node on the basis of which connectivity node was produced and which terminals are connected around.
And that's in the, sorry.
So it's the relation between the equipment and the TP.
Yeah. And what and where is that in what file or what?
Yeah, so each connectivity node, I think it's in the TP. So the link between the connectivity node and the topological node.
Okay.
So in general, the terminal is not really removed. It's just that picture is saying that those are considered irrelevant for the power flow. But when you're dealing with measurement, of course you want to have them in. If you want to do something like a state estimator, or simulating events that is happening.
Exactly.
So the terminal is still there. So,
Yeah.
but it's not necessarily used in a bus branch. That's the reason the drawing is they are taken away. But and then in general, you're not considering the values on the switches if they're open or closed and things like that.
Yeah, and that kind of information is put in the TP file.
Yeah, in EQ, well, you would have all the terminals and all of the TP would link primarily the connectivity nodes, as we said now. But in the current, you can actually also point the terminal to the topology as well. So you can know all the terminal. But I think it's now set as an optional field, but the connectivity is a mandatory.
Yeah, you can see the TP, basically the link between the SV and the connectivity-based equipment. So it gives you the transition, how if you have a voltage in the terminal, where that you can have it on the node breaker model if you want.
Okay.
Tania, do you want to intervene? I see you're writing in the chat.
It's enough. I think I wrote, people can read, so it follows up exactly this discussion. I try to put it in my words as well, to confirm that if you have detail, like we now do with CGMES 3, starting from connectivity nodes and all details, you can always reduce that to T-node, topological nodes and bus branch. If you have pure bus branch as input, you can't deduce where it comes from and all of this. So you always backtrack from that solution, which is the minimum. You have the means to track back to EQ via terminals and connectivity nodes. That's it. Thank you.
Thank you, Tania, and thank you for your question. I see Miguel. Miguel, quick one maybe, or if it's a long question, we can keep it for the...
It's very simple question. Regarding to the persistency, in terms of these slides, Stefan, regarding to what is in 2.4.15 and 3.0 in terms of connectivity nodes, topological nodes, terminals, and so on, the persistency is in both sides, in both domains, 2.4.15 and 3.0, in the same way.
Can you clarify the question, Miguel, again, please?
Yes. The idea of the persistency is to know which one are the identifiers that should be maintained during the time. So for the case of 3.0, regarding to the topology processing and taking into account that depending on the status of the busbar couplers and switches and so on, will change the TP depending on which are the topological nodes that you are going to obtain. The requirements for the persistency is the same than in 2.4.15, or this situation has changed?
So you could see it as the SV, where you also have non-persistent IDs, because SV is the result of a calculation process. In 3.0, we can consider the TP as the result of the topology processing. So it becomes output data, and output data, the persistence is not needed. Of course, if vendors made a tool that is 2.4 compliant, there will be an algorithm inside and in place that will guarantee persistency. So if we relax the constraint that the topological node needs to have a persistent identifier, it doesn't mean that the tool cannot provide accidentally or unaccidentally always the same identifier. So it does not say that they accidentally might not be persistent, but it is not a requirement in 3.0.
Thank you, Stefan.